I welcome you all for the fourth session of this FDP, Design and Career Opportunities for IoT, LTA, RF Front-Ends. It's my pleasure to introduce our resource person for the fourth session of the FDP, Dr. R.M. Joni, Associate Professor in Satyabama Institute of Science and Technology, Chennai. She has completed Bachelor of Engineering, Electronics and Communication Engineering at Madurai Kamaraj University and PG in Applied Electronics and PhD at Satyabama Institute of Science and Technology, Chennai. Our chief guest has 11 years of experience in teaching engineering subject and 4 years of industry experience in Wipro Technologies. I'm delighted to say our chief guest is the gold medalist in ME. She has authored 5 book chapters and has published many papers in various journals and conferences. She has acted as a resource person in various seminars, faculty development program, and workshops. We are very happy to have you with us, ma'am. Now I request our chief guest to take over the proceedings.
Thank you, sir. Thank you so much for the warm introduction.
Thank you, ma'am.
Thank you, sir. Thank you. Can I share the screen, sir?
Sure, ma'am. Just give me one.
Yeah.
Sure. Yes, ma'am, you can proceed.
Yes. Okay. Thank you, sir, for the warm introduction. And very good morning and warm greetings to everyone. Hope everyone is safe and well at home at this situation. I take this opportunity to express my deepest gratitude and earnest thanks to the management of Mailam Engineering College, Mailam. I also thank Dr. S. Ganeshan, Professor and Head of the Department of ECE, for convening this AICTE Training, Learning and Academic Sponsored ATL 1-week faculty development program on 5G antenna design engineering. It is indeed unique pleasure and privilege for me to express my sincere gratitude to Mrs. J. Sukanya, Associate Professor, and Mr. S. Ramesh, Associate Professor of Department of ECE, and Sir, who has introduced me for having invited me to deliver this session in this FDP. And my special greetings to all the participants. And once again, I welcome you all to the session 4 of the 5G antenna design engineering. And today's session, it is all going to be about the design and the career opportunities for IoT, LTE, RF front-end circuits. And so let's have a see-through of the 5G technology and how RF front-end circuits are going to be helpful in designing the antenna platform for the 5G network technology with respect to the Internet of Things. So we all know that in the recent days, there is a hype around the 5G. So unlike the previous technologies like 4G, there is not a uniform 5G network. So that is, we don't have a single antenna. So it is more than the evolution of the previous technology. So it is a whole set of networks for different applications. So the promises of the 5G standard are being great. And the maximum speeds we are able to achieve up to 20 gigabits per second, and the minimization of the signal propagation time, that is the latency, and many simultaneous mobile devices per area let all wireless experiences seem instantaneous and opens the door for the newer applications. So that is where the 5G stands. As we all know that the 5G standardization for the mobile communication which means that the name 5G has been coined from the International Telecommunication Union. So we all know the basics about all this information. But even then, I just need to have a quick recap and refresh all these basic things. So it was the 5th generation mobile communication system. So to this end, the standardization organization, that is the 3GPP, that is the 3rd generation partnership project, has advanced its 5G implementation with the International Mobile Telecommunication, that is the IMT, in 2020 initiative. So in parallel, the other standardization bodies, including the IEEE, well, we all are familiar with IEEE, that is the Institute of Electrical and Electronics Engineers, and the ITU, have combinedly worked on the 5G specification. So late 2019, the standardization process was finalized, and we now see more and more applications being commercialized. So as various frequencies we are used to transport a signal for different applications, we need to have specialized and the dedicated antennas are being used. And that is where the research and the basics of antenna concepts are required. So the variation of the frequency bands used for the communication are the one reason why we see more antennas, and that is why we go for the various design of the antenna with the more specified, the more specifications, parameters that we need to consider. So coming to the 5G, the specialty about the new radio technology, that is the NR, which is requiring the line of sight communication, is the other reason why we go for, or the need for, more antennas. So as the demand for the frequency continues to grow, we have this FCC, that is the Federal Communication Agencies of the US. They were reallocating the free and the vacant frequencies that is being not used in the 4G. So by reframing all these things, the already allocated frequencies for 5G are granted the operating license. That is how what we are using in the network. So the network operators, therefore, are free to decide which mobile communication technology they wanted to use. That is how we have so many service providers and many services being offered with the different packages. And so that is all about the basic information about the 5G. And we all know, I just wanted to give a comparison of the 4G with 5G. So this fourth generation communication system, it has the enhanced 3GPP technology, which was developed by the IEEE, which introduced the term called the LTE, long-term evolution. We all know about that. So furthermore, it has the compatibility that is with the previous version, that is easier deployment with the existing infrastructure and the technology. We need not to go for the design of the systems from the scratch. And also we had the simultaneous transmission of voice and data that was possible with the LTE system, which significantly improved the data rate. And also it included all the services, including voice services and the transmission of voice over the IP protocol, that is the internet packets in the form of packets. And also we know the information that the Geo was the first one to introduce the transmission of voice in the form of packets. And also they used the complex modulation scheme techniques and the carrier aggregation process, which is used to multiply the uplink and the downlink capacity. Also, we know this terminology, that is the WiMAX, that is the wireless transmission technologies, that was introduced in the 4G system to enhance the data rate and the network performance. So the key features of the 4G system are the much higher data rate up to 1 Gbps, and the enhanced security and mobility and the reduced latency. And we also have the high definition video streaming and the gaming sequences, as well as VoLTE, that is the voice over long-term evolution network. It is with the help of the IP packets. Also, these were the advantages and the key features of the 4G system. We also had some disadvantages. That is, it required a lot of expensive and very sensitive hardware and infrastructure. Also, getting the license for the spectrum, it was quite expensive, and most of the countries and the frequency bands that was allocated, it was too expensive. And universally, it has to be followed. And also we need to make use of the high-end mobile devices which are compatible with the 4G technology. So it is quite expensive. So we all use the smartphones. That comes the introduction of the smartphones. And also, because of the wide deployment, it required the upgrading of the systems to be time-consuming. That is why we don't have it took a lot of time to have a full-fledged 4G network. So before the implementation of this 4G network, the 5G has been introduced worldwide. So coming to the fifth generation communication systems, so it was rather than the 4G, we had some of the advanced technologies that is used to deliver the ultra-fast internet for many multimedia applications. So the requirement of the technology is that we need to have a lot of multimedia experiences with the evolution of this augmented reality and virtual reality. So coming to the current long-term evolution, advanced networks, they have transformed into a supercharged 5G network in the future, at least in the recent days. So the main technology, we all know that is that is the millimeter waves, and the unlicensed spectrum of the data transmission was being used. And with the complex modulation techniques and the supported systems, we made use of what is that? Massive data rate was supported for the recent technology that is called to be the Internet of Things. So that is being the talk of the market in the recent days, and that is the recent trend in the technology of communication. So because of this Internet of Things, we need to form a cloud-based network architecture. Therefore, the data rate, it should be high, and all these are being used for the real-time applications. That is the analytical capabilities of industries, autonomous driving, healthcare, and the security systems, highly secure systems. 24/7, we have the security surveillance systems going on around the society. And the key features of the system being the 5G system being the ultra fast mobile and the low latency. So that is, it is very fast, and there is a total cost reduction for the data and highly secure network. And with the what is the use of technology called to be the small cell technology by means of beamforming methods that is being adopted in the antenna design to improve the efficiency. So all these technical terms we might have come across. And also it has the forward compatibility network that offers further enhancement in the future. So that is what we need not disturb the already existing infrastructure which is being implemented. Also, it offers cloud-based infrastructure which provides a power efficiency, easy maintenance, and easy upgrade of hardware with the centralized system. So we have a common centralized system wherein all these parameters could be controlled and monitored and could be upgraded to the latest technology. So that, these are the main key features of the 5G systems, which is being more suitable for the Internet of Things and the recent advanced technology that is being introduced in the market for the real world and the real-time applications. So this is a comparative chart of the evolution from 1G to 5G. So with the expiry of this UMTS, that is the Universal Mobile Telecommunication Systems frequency, this 2 gigahertz band at the end of 2020 and this 2025 has allowed these frequencies to be allocated for this 5G. And this worldwide, there is the unused 3.5 gigahertz left behind by the WiMAX technology. So as a result of this, 2022, this 300 megahertz bandwidth will become available for 3.6 gigahertz band of frequencies, and that will range from 3.7 and 3.8 gigahertz. And we have that NR, that is the new radio technology, which uses this millimeter wave range, and that starts from 24 gigahertz and extends up to 54 gigahertz. So possibly we would be able to provide 64 to 84 gigahertz range that will also be added in the future. So coming to this 1G technology, what is that? We made use of this, the first generation of systems, which was using this AMPS, and the technology was this FDMA technology. So it was able to support 1D, that is networks which offer the channel capacity of 30 kilohertz and speed up to 14.4 kilobits per second. And it offered only those voice services. We might have come across that is such mobile phones in our childhood days. Is it not? So right in that is next is the second generation. So despite there were flaws in that 1G network, and it was superseded until 1991 when 2G networks were introduced. So based on the signaling, digital signaling technology for that GSM, wherein the GSM was first introduced in the 1990 to 2000, we had the data rate speed up to 9.6 to 14.4 kilobits per second with the technology TDMA and CDMA, which was providing additional services like voice and the data services. So wherein we were able to talk as well as we were able to send the SMS. Is it not? We might have also, we also used to send MMS messages, although at low speeds, we were able to achieve up to 64 kilobits per second with the later improvement. And with the continuous improvement in the, what is that, the GSM technology, that led to the introduction so-called 2.5G, which incorporated packet switching in the form of GPRS, that is General Packet Radio Services. Also, that is the edge technology. We all know that. Enhanced data rates for GSM evolution, which had the data rate up to 144 kilobits per second, enabling the users to send and receive email messages and browse the web applications. So these were the things that was introduced in this second generation mobile systems. And coming to the third generation, with the arrival that is in the late 2000, what happened of this 3G, which is known as UMTS in Europe and the CDMA 2000 in USA. Here, the change in the way of mobile applications. So also based on this GSM, with the main aim of 3G was to support high-speed data and the original 3G technology that allowed data rates up to 14 megabits per second. So with its ability to transmit greater amounts of data at higher speeds, these 3G enabled users make video calls. They are able to surf web and share the files and play online games, even watch a TV online. Whereas these 2G networks would enable 3-minute MP3 song to be downloaded in around 6 to 9 minutes. The same file would take anywhere around between 11 to 90 seconds to download in a 3G network. So that is the evolution that has happened in 3G. And today, the most common use of 3G networks is the backup of the 4G network. So we all know all about that. So we are all familiarized with that. Yes. And coming to the fourth generation systems. So with the introduction of 4G, what happened? The really shared thereof the smartphone, the handheld mobile device. That is the fourth generation or first generation used the AICTE technology to deliver the theoretical download speeds of up to 10 megabits per second and 1 gigabits per second, offering the end users the better latency, there is less buffering, the improved voice quality, the instant messaging services, and the social media applications, quality streaming, and faster download speeds. So we all have witnessed all these generation of mobile applications. And this 4G is also the first IP-based mobile network handling voice as just another service and technology being developed to accommodate the quality of service and the rate requirements required by the applications, including the wireless broadband access and the multimedia applications, as well as the messaging, that is services such as MMS, video chat, and HD TV content, and the DVB, that is the digital video broadcasting. Okay, so that is all about the 4G. And later in that, in a relatively short time since the introduction, that is, however, this 4G networks already being struggled to cope up with the demands placed on them. It has driven by the emerging technologies such as augmented reality, autonomous vehicles, and the exponential growth of the Internet of Things globally. And the global demand for the mobile bandwidth is growing at an explosive rate. So because of that, the technology giant, Ericsson, predicts that compound annual growth rate, that is CAGR, to be of 39% in the global mobile data traffic between now and 2023, and equating to a total of 107 exabytes per month. So as well as being the bandwidth requirement and the bandwidth hungry, what happens? The emerging applications need high speeds and lower latency and growing number of IoT devices for fueling the demand of a higher number of connections to over 29 billion of 2022 according to Ericsson database. So with all these, we are able to support all these applications. And later on, we had this 5G introduced with the newer radio technology, which is going to provide the smarter applications, and it uses shorter wavelengths due to higher frequency, which means that the antenna could be much smaller than the existing antennas, which are still providing precise directional antennas, which means that it can support over 1,000 more devices per meter than the 4G can accommodate. Which means that the 5G networks can beam ultra-fast data at a lot more uses with high precision and little latency. And the key elements of the 5G new radio technology infrastructure is that the active antenna arrays, and it is allowing what is that multiple input and multiple output, that is MIMO devices. Is it not? We have come across all these terminologies. And the 5G revolution, what it has done. So this ITU specification for 5G contained in the document of this ITU and RIMT of 2020 evolution in 5G, which has been told that the ambitious specification represents a step change in the performance over 4G and aims to address the requirements of the emerging applications. So that is all about the 5G. So this is this slide is about the representation of the size of the mobile that is being used right from the 1G to 5G. We might have come across many such pictures. See, this is the stepping stone of the evolution of 1G to 5G right from the 1980s to 2020s, and now we are in 2021. We all have witnessed all these upgradations and the evolutions and the revolution that has happened in the mobile technology. Okay, so coming to the comparison of the 4G network with the urbanization that has happened with the help of the 5G network. So this is the requirement of the 5G network. You see a single antenna that is being from the base station, we have the network coverage of 5G. So at some places, the signal strength will be weak because we don't have the directional antennas. So that is the drawback of 4G. So coming to the 5G network, we have the highly active directive antennas, and the directional antennas were used. So this picture shows the 4G network compared to a 5G urban installation with active directive antennas, which provided better services compared to the 4G network. I hope we are in the flow. And this is about the 5G, just a picture description about a 5G antenna, which is being mounted on a base station. And this is the 5G, that is MIMO array antenna, beamforming antenna pattern, which is being superimposed on a real installation. So it is a simple representation that is being addressed by this Altered Solutions Technologies, where they have superimposed the beamforming technology on the simulation on the real antenna implementation. So with the help of this, we are able to achieve all the higher data rates and the directive antenna being providing very good coverage to the services. So we all know that this new radio 5G technology uses shorter wavelengths due to higher frequencies, which means that the smaller antenna, smaller than the existing ones. So since one base station can accommodate many directional antennas, it means that 5G can support up to 1,000 more devices. So unlike the previous generation of this mobile communications with GSM, this 4G LTE support does not undergo this fundamental technical changes. That also we know all about that. So that is all about the 5G technology, and lot more has been introduced with the help of this 5G network. So these are the key features. Again, the ultra fast internet with a smartphone, which will do better significantly improved network connection, and there are newer opportunities to deliver the groundbreaking solutions to reach across the society. And we have billions and billions of connected devices gathering and sharing information in real time to reduce the road accidents, life-saving applications that take flight tanks, and some of the predictive applications in real time in case of the medical applications. Even in the recent days, the operations or surgeries are being carried out with the help of the advanced technology, with the help of augmented and virtual reality, with the help of the robots as well. So all these high-end sophisticated systems need to be interconnected, and all these are hard real-time embedded systems. So a single latency or little minute delay in the reception of data would cause to fatality. So this it plays a major role in all these sort of real-time applications. So this, we all know that this 5G runs on the same radio frequency. It is already being used by your existing smartphone. So that is the specific feature. So on these Wi-Fi networks as well as in the satellite communications, but it enables the technology to go for a long further. So beyond, we are able to download this full length HD movie in our mobile phones, even in a crowded location. This 5G is all about the connecting things everywhere. That is where this Internet of Things has come. So without the lag, we are able to understand and get connected with the people in all real time. Is there some interruption, sir? Anything? Okay. And there is an enormous potential, and together we can take ahead to the next generation of mobiles. So this is all about, again, a pictorial representation of the 5G technology with respect to the various aspects. So this is about the 5G network architecture, wherein we are able to connect all these devices with the network services, local service provider, and the GPS front-end devices, and many, many more things are being used here. Before that, we all are using this, what is that, cellular telephone at our home. So everyone, so it has become a part of our human life. Like we carry all mobile always, wherever we go, 24/7. Is it not? Cellular mobile phone. Can anybody tell me who is the, I put for the question to you, to the audience. Can anybody tell me who is the inventor of this digital cellular telephone? You can respond in the chat box. Sir, is the chat box enabled, sir? Yeah. It is the most familiar one. Many of us would be knowing. Yes, sir. Thank you, sir. Many of us would be knowing Mr. PNR has responded as Jesse. Yes. So just for your information, let's know that Mr. Jesse Eugene Russell is the inventor of digital cell phone, who had worked with, he's an African American scientist who had worked with the Bell Laboratories. He was the first one to invent the digital cell phone, what we are using in the recent days, wherein while he was working in that Bell Laboratories, they have invented this telephone, which was to support the telecommunication technology that was developed in those years. So coming to the evolution of mobile phone. So this is the evolution of mobile phone that has happened right from your bigger telephone to the smallest telephone. So this is all about this cellular technology, wherein the various technologies that we were using in the recent days, right from your CDMA technology to the 5G technology. Okay, so that is like from 2G we use GSM and the 2.5G GPRS and the edge technology, CDMA technology, and the what is that for that is the time division duplexing technology, and many more applications that we were using in that. So coming to the main theme of the work, this today's thing, RF front-end module. So what is RF front-end module? So this RF front-end is a device or module that incorporates many of the circuits. So it is a device or a module that incorporates all the circuits that is between the antenna, at least one of the mixing stages of a receiver, and possibly the power amplifier and the low noise amplifier that is for the transmitter. They are used in a wide variety of RF products and many more applications. And most of the applications that is included for this mobile applications. That is the 5G network. And what is the role of RF in the 5G communications? So these radio waves are used for the communication in the 5G technology. So like in previous mobile networks, these 5G devices will communicate with the base stations by transmitting and receiving the radio waves or the radio frequency and the electromagnetic waves. So how does this RF front-end work? So this RF front-end is a generic name of all the circuitry between the receiver antenna input into up to the mixer stage. Its role is to remove the image frequency and to prevent the strong outband of signals from the saturating the input state. And this RF amplifier, which is used to amplify the weaker signals without adding noise. So this RF front-end is a device or module that incorporates all the circuitry between the antenna and at least one of the mixing stages of the receiver, that is being possibly the power amplifier of the transmitter. So they are used in a wide variety of RF products and many other applications in the 5G network. And they may also include the frequency generation circuitry. So although it is being used for this many more 5G applications, this RF front-end devices that is specifically used for this FM radios and the television receivers, our receiver only being the front-end. Here, this RF will be used for all the GSM as well as this 5G applications. So they typically feature the double balanced mixers for improved intermodulation characteristics, signal limiting or clamping the circuitry to prevent overloading the local oscillation buffer and impedance matching. So this refers to a single device that is used in a circuit with additional filtering, the power supply decoupling, and the matching circuitry that are impractical to implement on chip. Therefore, it can also refer to a whole circuit offered in a modular form. So this is all about the RF front-end module circuit in detail, wherein we have many blocks playing a key role in the implementation of the RF front-end module for the 5G technology. So this GPS front-end that is being used module are being the receiver RF front-ends. They have the RF input to a built-in bandpass filter that is being centered at 1575.42 gigahertz, a low noise amplifier, and may incorporate a double balanced image rejection mixture to convert the lower intermediate frequency. So this IF could be the lower frequency, for example, 16.384 megahertz to 4.09 megahertz. So they usually require the external circuitry like SAW filters. We might have made use of in our design of all these bandpass filtering for the selectivity of the particular gain of the signal. And the low noise amplifier that is being used here is the one that is being used for the variable gain amplifier after the mixer to amplify a low precision analog to digital converter to produce a serial bit stream, for which we will be making use of the subsequent digital signal processing to recover the GPS clock for the reference. And they can include the built-in frequency synthesizer and the local oscillator to produce the local oscillator signal for the mixture. The configuration is typically by the serial interface of the processing system. And also here we have the baseband modem, and we have the millimeter wave baseband modem, which is more specifically being used for the 5G technology. The wireless LAN and the Wi-Fi RF technology, Wi-Fi LAN or the RF technology front ends are being used in many applications, such as the smart meters, the intelligent lighting systems, routers, and the cellular device. So they incorporate the power amplifiers being used here for transmitter and the low noise amplifier for the receiver and RF switches for swapping between the receive and transmit. They may have the second switch to allow the auxiliary antenna to be used for the balance to perform the impedance matching, and balance to unbalanced conversion are also typically being incorporated. So they may comply with the wireless interface standard, that is the IEEE 802.11g for a Wi-Fi system, and have additional antenna switching to support this Wi-Fi and the Bluetooth module. And the software tools like Altium Designer and the SolidWorks and CSU Microwave Studio, we all know about that, are being used for the design of these RF systems, and many more tools are being introduced in the recent days. So now let us understand why RF is very important to 5G. Sorry for the interruption. So we were discussing about the RF, why RF is important to 5G. So now is it audible, sir?
Yes, ma'am. We are audible, but background
Yes,
we hear some noise.
Yes, sir. That's what, sir. I just give me a few more minutes. I'll just...
Sure.
Sorry, sir. It was a construction work going on. I've asked them to stop. Sorry for the interruption.
No
I'm
problem.
really sorry.
No problem. Thank you.
Sir. So why RF is important to 5G? So this advanced RF technology is being a key for the 5G and especially the millimeter wave bands because it solves the line of sight problem by steering signals around the objects and can even bounce signals against building walls in order to reach the user equipment. So that is so this picture shows the various technology that is being deployed for the RF front-end module. So this shows how this LTE and the 5G technology being used here for this implementation. And next, what is being introduced here in the 5G to IoT tech, that is Internet of Things, which is being the fascinating word here this in the recent days. So we all know that the Internet of Things is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange data. So this IoT allows objects to be sensed and controlled remotely across the existing network infrastructure, creating opportunities for more direct integration between the physical world and the computer-based systems, and resulting in improved efficiency, accuracy, and economic benefit. So we all know that what Internet of Things is. So things in the IoT sense that can refer to a wide variety of devices such as heart monitoring implants, biochip transponders on farming animals, and the electric clamps in the coastal waters, automobiles in the built-in sensors, and the DNA analysis for the environmental, food, and pathogen monitoring. So there also we have many field operating devices that will be assisting the firefighters in the search and the rescue operations. So these devices collect the useful data with the help of the various existing technologies that autonomously flow the data between the other devices. The concept of Internet of Things being the first became popular in 1999 through the Auto ID Center at the Massachusetts Institute of Technology related to the market analysis publications. The radio frequency identification with the help of this RFID that was seen being the prerequisite for the IoT at that point. Sorry for that, sir. So coming to these wireless standards, while these 5G wireless standards are still under development, so it is not too early to predict that 5G device designs will be more complex and the more components, particularly filters, can be expected to deliver higher networking and processing performance. At the same time, they will be smaller and less expensive. So this 5G networking standards are now under the development to accommodate the wide variety of use cases that are now being served to with the disparate technologies that are being used here in case of the 5G technology. So these range from low bandwidth, that is the Internet of Things, to high bandwidth video. So the challenges that come with accommodating these use cases will impact the every part of the 5G deployment, but perhaps will have the most complexity and challenge to RF front-end in the mobile devices. If for no other reason than there is a very little space to accommodate this complexity. So we all know that this Industry 4.0, which is being the revolution that has been created in the industry. This cloud computing, with the help of all this technological advancement, cloud computing, the automation of the industries, system integration, and autonomous robots, big data, the cyber security, and the smart factories, this industrial revolution has been introduced. And now we are stepping into Industry 5.0. So it has led to the tremendous introduction of the 5G. So that is the requirement of the 5G in the IoT technology. So, and also we need to have a lot of challenging things for the system integration of all these highly sophisticated environments. So being the future of this, 5G technology, this radio access networks, we have this expected to be the combination of technologies, nodes, and frequencies, and this mix will result in one of the biggest challenges for the 5G deployment, which is going to be the densification of the network and the new models that make the deployment economically viable. And planning for the 5G deployment will be extremely difficult, and large number of nodes will make non-optimum sites the normalization of the industries. So increasingly, the deployments will include the shared equipment between the carriers. And the dynamic, the adaptable and allocation of resources to maximize the performance, and the increased automated software control, which has led to the evolution of the smart world. And the coordinated multi-point will be required for efficient spectrum usage, and the accurate channel state information will be critical to correct the allocation of resources. So the many different cases are being introduced for the 5G, which is going to accommodate a set of network and significant network settings, functions, including the radio access technologies that is going to be referred as the 5G slice. So the idea behind 5G slice is that the overall environment is being maintained with only the necessary functionality for each use case to efficiently allocate the available resources. So given the technical challenges which is being outlined here, the conclusions about the end users devices, wireless devices, practically the mobile broadband phones, and these devices will exist in an environment that includes more and more complexity of the applications. So coming to the smart world, so we all know the entire society is being converted into a smart world. First, we create a smart community of the place where we live, then smart cities, then smart countries, and then finally the smart world. So where it is marching to? So a smart world will be having the smart grid and the hybrid renewable energy systems, smart sensors with the IIoT. We also know that terminology, industrial Internet of Things, and the integration of sensors in robots and artificial intelligence, and the impact of electronics in the smart city, and the 5G technology, which has led to the human-machine interaction and the various communication protocols that is going to support, and all these factors are going to be impact with the evolution of the recent trends, that is the virtual reality. So we all might have understood about that smart world. So you might have come across many such videos. I just wanted to have a glimpse of a 1 minute video clip, 1.5 minute video clipping about this smart world. So can anybody tell, is our society which we are living here is being converted into a smart city? Can anybody tell me? The place which we are living, it is being converted into a smart city. Do we have smart cities in our country? Yes. Can anybody respond? Yes. Mr. PNR is responding. Yes, we do have smart cities in our country, but still our Chennai, the place where I am staying here, is still in the process of conversion of deployment of being declared as a smart city. So I just wanted to have a glimpse of the video of the already existing smart city of New York City, which we have come across. I just wanted to showcase it here. Sir, are you able to hear the audio, sir?
Yeah, yes, ma'am. Yes.
Yes, sir. So that is about the smart city New York, which we have the database of all the people moving around the road, and the technical information, right from the garbage disposal to the many of the people, like from the lower state of the people to the higher state of the people. Many more applications are being there. Everything, cyber security, all the systems are being integrated, and the cyber security infrastructure for the help of the face recognition technology, and the society of people of public housing, we have the smart devices. With the smart devices, we are able to control the entire thing, and they have a report and database and monitoring of all the entire work that is being carried out here. Even the kids are exposed to the digital literacy, and we have the common charging stations and many more applications. This augmented and virtual reality. So with all these things, a city will be declared as a smart city. So where the 5G is going to play a major role in that. So we all know this, all this information about the smart city, and the purpose is to, what is that, drive an economic growth and improve the quality of life of people of the society. So with the help of this Internet of Things, which makes use of the connection of all the devices with the help of sensors, lights, and meters to collect the database and analyze the data. So that is about the smart city. So it is going to be the various features of smart city. Let me quickly go through some of the pictures where the smart environment is being created. So the first one is the augmented reality and the remote place where we are not able to have the physical transport for the courier service. It is being deployed with the help of the remote drones. And this one is about the cyber security for the surveillance and the automobiles with the smart environment and the electronics in the smart city. That is, we have the automatic turning on, off and on of the lights with the help of the sensors being deployed in the streets, across the streets. We have also witnessed at some of our places. And also this is a smart lighting system with the 3GPP technology and the wireless surveillance camera. For all these applications, this 5G is playing a major role. So that is the intention of showing all these pictures here. Okay, and we might have come across these sort of scenarios in the real-time life where we have this automatic and smart parking systems in the shopping malls, which will be indicating the vacancy of the parking slot with the help of this LED indicators, with the help of the sensors connected in the network, and that will be controlled by a common centralized center. And this is about the automobile, where we have a lot of revolution in the automobile industry. We have the wireless, that is driverless automatic cars, that is Tesla. You all know about that. And this is about the various technologies, smart buildings being integrated, and it has reached the farming industry as well. So we also know about all this information. So here we have the automatic robotic system, which will be monitoring all the plants and crops, remote monitoring without the human intervention. So this one is the automatic robotic system, which will be looking into the what is that status of the fruit, whether it is in the ripened state, and we have the smart sensors and the cameras, which will be giving database about what is that the status of the fruit, whether it is in the ripened state. And this one is about that augmented reality with the help of this smartphones and applications that is being developed. It is giving database of whether it is in the ripened state for getting plucked. So all these being are deployed, and the remote monitoring of the fields and crops with the help of these drones. And we have this medical applications, and even in the recent days, because of this COVID times, we have the centralized monitoring systems, and many places where this team without the human intervention, we are able to do the surgeries as well as to monitor the patients. Even in the ICU wards, they keep monitoring the patient's status with the help of a lot of sensors being sent to a centralized place. So all these being are done with the help of this 5G network. And the security and surveillance applications, these also we know that. Let me quickly go through all these things because we need to see some more important points here. And this avionics, that is also an important point here. And the smart transportation, we are able to keep track of the transportation of the vehicles, the location of the vehicles, and the control of all the signals of the transport from a centralized station. And we have much more applications in the defense as well as in the satellite communication. Most of us are the communication engineering field, and we all know about what satellite communication is and how it is going to play a major role right from the signal reception from the satellite to the base station here at the end users with the help of this 5G technology. And finally, your augmented reality and virtual reality, which is going to help the medical applications. We are able to diagnose the disease even without having the touching the body itself. Okay, we have the powerful and sensors and cameras and devices which will be doing all these applications. And many of the things are being used nowadays for the study purposes, study and educational research purposes. And finally, the 5G is going to play a major role in all these applications. Is it not? And finally, your mobile and cellular mobile communications. So this 5G is going to carry all this image information, your voice data, as well as your data information. So all these things should be supported without any flaw in the circuit. So that is why we make use of this multiple input and multiple output with the millimeter wave technology that is being reported here. So as per the future technology that is being reported here in October 2020, in the recent month, Samsung, Huawei, LG, and some other companies have already started to work on the 6G technology, which is going to be the next generation of technologies. But still, it is not being introduced here in our India. And we all know that this 5G can offer us the speed up to a downloading speed of maximum of 20 gigabits per second, and it could support 3.7 gigabits per second during the testing of the 5G network in India. So the three companies have come forward, this Airtel, Y, and Jio have conducted a speed test of up to 3 gigabits per second in the 5G networks. So what is going to be the future, or what will be the technology in the future? Can anybody tell? Yes? What is going to be the future of this 5G? So already 6G is being in the talk of the world. Still, any guesses? Any guesses about the recent things that has happened here? So in the month of November or so, our government of India has signed a technology, introduction of new technology to have a better improvement of the already existing 5G technology. So the drawback here in the 5G technologies, as we are using the high frequency signals, it is very difficult for the signals to penetrate through the walls. So that is why we get, at some places we don't get signal, and there will be signal drop at some locations. Is it not? We have come across and we have witnessed such scenarios. So they introduced the technology called the Wi-Fi Alliance. That is, the company has given the certification and verification for the technology called to be HALO, H-A-L-O-W, HALO, which is going to be the latest Wi-Fi technology that is going to hit the market soon. Soon they have signed an MOU with the Alliance. They have certified this technology according to the reports of the media. So the next generation of Wi-Fi, it is going to be the dubbed Wi-Fi HALO, and it has been certified by the Wi-Fi Alliance. So what it is going to do, it is going to play a major role in Internet of Things. So this new Wi-Fi HALO networks, it is going to use the sub spectrum, that is the sub 1 gigahertz spectrum, rather than this 2.4 to 5 gigahertz that is being used for the 5G technology. So this frequency allows the transmission at a high amount, and it can easily penetrate through walls. So it is actually more required. So the important point to be here noted here is we need not change the existing router or the Wi-Fi system that we have at our place. So with the existing system itself, it is able to support all these frequencies. There is HALO technology, which is going to be operated at the frequency of 900 megahertz. That is the sub-gigahertz frequency. So it is going to provide a better service. So it is going to be standardized by the IEEE. It is the IEEE 802.11 AH technology. So that is going to augment with the Wi-Fi operating system that is below the 1 gigahertz to offer a lower range and lower power connectivity. Because the devices which we use of low-cost devices, some of us use low-cost devices, it is of size small and requires low operating power, and everything is comes into picture. So this Wi-Fi HALO meets the unique requirements of the Internet of Things that enables the variety of end users to meet the demands of the industrial, agricultural, smart building, and the smart city environment. And so we need to make use of these sensor net. It could also be enhanced for a sensor networks as the distance of coverage would be 1 kilometer. So it is more suitable for the Internet of Things applications. And also nowadays we have come across the wearable antennas, is it not? So even for medical applications, we have seen this main use of these Fitbits, is it not? Some of the wearables which will keep monitoring our health condition. Personally, we do it, and many more devices, electronic devices, are into the market, which is actually required for this. What is that? Wi-Fi HALO. So there are more facilities and more comprehensive approaches to the Wi-Fi technologies, and so it is of more benefits to the customers because it provides the multi-vendor interoperability, easy plug-in play devices, easy setup without disturbing the already existing infrastructure, and it provides the latest Wi-Fi security as well. So this Wi-Fi Halo joins with several Wi-Fi technologies, which is going to provide low power, high performance, and highly secure network, and that is going to support the IoT environment. And so this is some of the comparison of the various frequency ranges that is being used for the different applications. So if you wanted to go for a real, virtuality and augmented reality, we'll be going for the Wi-Fi gigahertz operating ranges and Wi-Fi 6E for the different applications, whereas this sub 1 gigahertz will be used for within a particular locality where this Wi-Fi Halo is being introduced. And this is some of the features and benefits of this Wi-Fi Halo technology. So it provides a very good spectrum, and narrowband OFDM channels are being used, and it provides a native IP support. We will not have the new installation of the separate network, and it uses the latest Wi-Fi security technology. It provides the long range coverage of approximately 1 kilometer, and most importantly, it provides the penetration through walls and any of the obstacles, as well as it supports coin-sized cell battery devices that could be operated for many years, and it does not require any proprietary hubs or gateways to get through the application devices. So these are the various features of the Wi-Fi certified technology by the Alliance Technology, which is going to soon hit the market in 2022. With all the certifications are being processed already. So this is how it is going to be. So if it is going to be a very hi-fi network, it is going to be 5 gigahertz within a house limit. There is 802.11 AC standard and 2.4 gigahertz, a little bit of wide range, and it is going to provide a very good signal strength for the IoT devices, and that is where we have come across the invention of the smart homes. So nowadays we have many of the smart devices at our home, like Alexa, this Google, everything, many more such devices we have witnessed. All these are being the IoT technology. So this is another picture that shows representation of the various Wi-Fi technologies. So coming to this, it is going to be the smart house application with the help of this Wi-Fi Halo technology. So now, where this 5G is marching to? So it is going to be the 6th generation. So 6th generation is already being introduced into the market. That is the various highlights of 6G are it is going to be the 50 times faster than the 5G. So already many countries have involved into the process of the evolution of the 6G network. So this 6G network, which has been introduced in Japan, which is expected to be launched in 2030, as per the reports from the media. And some of the countries like Japan and joining hands with South Korea, China, and Finland, we are preparing for the 6G network. But still in India, the entire 5G itself is not fully deployed. So we are into the process, and according to the report, millions of being spent in the European Union for the 6G network. And we have this, many more things. We need to have the sophisticated mobile devices and the automated cars with the help of this 6G technology. And coming to the last highlight here of the today's session, it is going to be the career opportunities. So what are the career opportunities right now here in the market? So this RF front-end modules market is expected to grow at the compound annual growth rate of 11.3% during the forecast period of 2021 to 2026. Therefore, this RF front-end design is considered to be one of the better and the feasible choices on the AICTE research, which consists of the S-band and transceiver that is fully implemented on the commercial off-the-shelf components, that is the easily plug and play for the end users, and the growing popularity of this RF SOI. So what is RF SOI? Silicon on insulator. So the RF front-end modules, everything will be on a chip, single chip, silicon on insulators. And with the increasing adoption in the smart devices into the market and many RF SOI systems are being introduced for this RF Frontend Module devices, and which is going to support this 3G, 4G network, LTE advanced, and the future of the currently existing 5G, as well as the future of the 6G networks, all being miniaturized. So we have advanced modules that could be integrated into smartphones. Nowadays, the size of the smartphones are being reduced. So we need to have the highly sophisticated antennas, is it not? So the base stations, as well as the personal computers use, electrical vehicles, IoT devices, and healthcare enabling the growth of the market. So, and the players are being focused on innovating the low power solutions, which will be significantly improving the range much more compared to the standalone, that is system on chip implementations, thereby minimizing and potentially eliminating the required antenna matching network. So all we go for substitutions. So the front-end module also integrates the highly sophisticated, what is it, power amplifiers, output matching, and the harmonic filtering, and the bypass path switching, which will be enabling the flexible and innovative end product designs for space constraints for the IoT applications. So these are the leading manufacturers of the various RF front-end devices and components modules. So module-wise, it is being picturized here. So this RF switch is being what is that, manufactured by the Sony, Skyworks, Infineon Technologies. Amplifiers are being manufactured by these other companies, and the filter designs are being done by these companies. So a lot and more design and research and design opportunities are there, as well as for the researchers like us, many more openings are there. And system integration of all these components are being done by Murata, Avago, Skyworks, Pewar, and TDK, and the Qualcomm is going to play a major role in the antenna design. So we all know about that Qualcomm company, is it not? And all these things are being integrated into a, what is that, RF SOI, or with the help of the handset device by the leading manufacturers such as Samsung, Apple, Huawei, LG, is it not? So discrete components are being manufactured by Lenovo, LG, MI, and other companies, and all these things are integrated into a single handheld device with the help of this Samsung and Apple. So many more opportunities are there, as well as coming to the government sectors. We have a lot of opportunities in DRDOs and your ISRO satellite communication, wherein antenna is going to play a major role in the communication purposes. I hope this session was very useful to you, and I thank once again for the AICTE for organizing such a sessions for the faculty like us to have an open forum for discussions in the future discussion of the future research. Thank you once again, the management of the Mailam Engineering College and the coordinator and all other faculty members who had been played a key role in organizing this FDP. Once again, I thank all the participants for being patient listeners. Thank you all. Thank you, sir.
Thank you, ma'am. Thank you. It was an excellent presentation, ma'am.
Thank you, sir.
And your slide preparation is so beautiful, and it's very excellent.
Thank you, sir.
Thank you. And we do have some questions from participants.
Yes, sir.
So, when we prefer MIMO technology and MM wave technology, 5G.
Yes, sir. When we prefer
MIMO technology and technology.
So this millimeter wave technology is for the frequency for which we are going to allocate that particular antenna. So when we wanted to have the multiple input and multiple output devices, that is many of the devices connecting to the same antenna, we need to have MIMO technology. So when we talk about the frequency allocation, millimeter wave technology. So, and when we talk about many devices connecting to a single network and multiple operations, because the single antenna which is being mounted on the base station that is going to provide services to the many of the devices that is getting connected by means of the directional antennas, is it not? So When we talk about the frequency of allocation, millimeter wave technology is there. And when we talk about many devices accommodated by a single antenna, this MIMO technology is there. So the integration of both the things in a single antenna, it is going to be the 5G technology. And the beam streaming, that is about the coverage of signals. Is it clear? So that is the most fascinating technology which has led 5G to the directional antenna way of communication for providing the services to the people without delay and supporting at all the times. Yes, sir. Have I answered your question, sir? Mr.
Yes.
PNR?
Thank you.
Yes, sir.
So we have another question, ma'am. Could you please
Yes,
explain about the beam security and privacy issues in 5G technology?
Security and privacy issue, like lot of technology, that is lot of algorithms are being implemented there, depending upon the frequency range of allocation that is being allocated for the particular thing, and what type of data it is going to carry, whether it is going to be the message information, or it is going to be the data information, or it is going to be the voice and the video information. All based on that, different security and privacy is maintained. So with the help of this, we know all this, this technology, which is being used for many more applications. That is for security purposes. Encoding methods, I'm talking about the different encoding methods that will be used.
Thank you, ma'am. And one final question. How wearable antennas, 5G and IoT are related?
Yes. So nowadays, wearable antennas were being introduced. Like we need to have the GPS systems in our jackets where we wear, and some of the GPS are being created in ears, some of the hair clips. So nowadays, safety and security of the women are being the top of the market. Is it not? Nowadays, there is no safety for the people and the child. Okay, so there lot of devices are into the market. So like wearable devices with the help of this GPS allocations, as well as in case of this medical applications, wearable antennas will be coming into picture, where it is going to have with the help of the sensors and this antennas being incorporated there, it is going to send the data, the real-time data, to a central base station who will be monitoring and providing security to the people who are using those wearable devices. So therein the wearable antennas come into picture, and 5G is going to play a major role for communicating the signals that is from these particular devices to the central station. And as you know, this IoT is going to play a major role in that. So that is about. So nowadays, even medical applications, all these are being used in the recent days.
Yes.
Yes,
Thank
sir.
you. Thank you so much, ma'am.
Yes, sir. Thank you, sir.
Once
Thank
again,
you so
I
much, sir.
thank you for this wonderful presentation.
Yes, sir. Thank you, sir. Thank you so much, sir. Thank you.
Thank you, ma'am. Participants, I would request everyone to turn on your camera for just 2 minutes so that we will have a group pic regarding the session. Kindly turn on your cameras. Ma'am, I would request you to stop the screen sharing so that we can take the group pic of the session. Yes. Yes, thank you, participants. Just for 2 minutes, just turn on your camera. Just give us 2 minutes. Thank you, participants. Thank you so much. That was an excellent session, even though it is an extended session, but it was really interesting. Thank you very much, ma'am. Thank you for all the participants for your
Thank you,
active
sir.
participation. We would start the second session by 11 a.m. I request all the participants to join the session in 5 minutes. So just join us on time. Thank you. Once again, I welcome you all for this fifth session of this FDP, Advanced Antenna Design and Simulation Controls using Sarang. It's my pleasure to introduce our chief guest for the fifth session. In this 5-day FDP program, Swapnil Gaul is a founder and director of Numerigin Technology. He has completed masters from IIT Kharagpur during 2011 to 2013 with specialization in RF and microwave. He has completed his project work, which was mostly on computational electromagnetics and numerical techniques, under the guidance of Professor Ramesh Garag. After masters, he worked in NI Logic for simulation software and EDA tools, including Alters, FDCO, ESI, STEM Solution, and Quickfield. He has demonstrated software in more than 75 engineering institutes. Just give me a minute. Participants, I request everyone to mute yourself. 134. 134, kindly mute yourself. Sorry for that. So after masters, he worked in NI Logic for simulation and software and EDA tools, including Alters, FCO, ESI, CEM Solution, and Quickfield. He has demonstrated software in more than 75 engineering institutes across India and provided consultation on simulation to various research organizations, ISRO and DRDO. He has also published 2 research papers. One was on RCS prediction with MOM, MLFM, PO, and PTD methods associated with Defense Laboratory Jodhpur, and other on EMC analysis of cable harness using TLM method, which was associated with ESI groups and published in Indian Antenna Week 2017. He has contributed in development PSO organization toolbox for MATLAB. While demonstrating the software to undergraduate students, he realized that many students are uncomfortable with using simulation tools. Yet there is need of unified solution where the goal is need to learn the software, but it is to learn the concept by understanding those simulations. After getting adequate industrial experience, he quit the job to develop simulation packages which will allow hands-on based learning experience. He continued his master project to make it from the product, started a private limited company to commercialize the same to achieve the goals in strategic manner. We are very happy to have you with us, sir. I request Mr. Swapnil Gill to take over the proceedings.
So thank you, sir, for giving us opportunity to present here. Thank you all the participants for joining this webinar. Before proceeding with this webinar, I would like to know about the participants, sir. Who are the participants for this webinar? Mostly faculties or students or for researchers?
It's a combined group, sir. Faculties, research scholars,
Okay.
and students as well.
Okay, sir, because in Terang simulation software, we have like different features which are applicable for a student also, for researchers also, and for industrial users also. So we have developed this indigenous simulation package, which starts learning of electromagnetic subject from basic to very advanced. So when we talk about basic, there are things like most of the undergraduate student or most of the learners who are very new to electromagnetic find difficult to understand this subject because there are like lot of visualizations required. If we see this Faraday's law, Coulomb's law, and some other laws like Biot-Servot's law and so on, so it is not possible to understand that subject with proper visualization or proper imagination. So if you build that imagination or if you show that visualization, then that subject becomes more interesting. Without that, this subject becomes very much difficult to understand. So our approach is that we are going to make these subjects very much familiar, very much user interface based design. So I will demonstrate the software and we will see that how we can make these subjects very much interactive. So yeah, I will be sharing the screen now. So my name is Swapnil Gaul. I'm founder of Numerigen Pune. And today we are going to discuss about Numerigen's Tarang software, and we are going to give the overview how this Tarang software is going to work for hands-on based practices. So if we see the different concepts which are available in the electromagnetic book, that starts from basic Coulomb's law, where we can put different charges, and we are going to find out the interaction between the charges, how this electric field are generated, and how these flux lines are getting showing that repulsion and attraction kind of behavior. So this kind of study we can do using Tarang simulation tool. We can put the charges, we can like shift the charges, even like we can move the charges. Anything is possible, and we can understand these concepts. The another kind of concepts that we can also understand is something like magnetism, where we can study Biot-Savart's law. We can take the current carrying conductors, and then we can find out the magnetic field generated by those conductors. Then in the next, we can also do moving charge simulation in magnetic and electric field. So when we are having moving charges, so we are like going to put some charges at some locations, and we are going to assign the electric and magnetic fields nearby to those charges. And when the charges are pushed by some electric field or by some velocity, and when it goes inside that electric or magnetic field, then how those charges are going to propagate or travel, that trajectory also we can plot. So mostly like these are the concepts which are there in most of the basic electromagnetic books. Another is like wave propagation, understanding of wave propagation, how we can make different waves together, and how we can make the polarizers, how we can achieve circular polarization, linear polarization. So these kind of studies also we can do by using this simulation tool. And after doing these basic electromagnetic studies, we can also move to propagation and antenna design problems. So there is like a full-fledged antenna design toolbox where user can draw any kind of antenna, and they can simulate these antennas, and they can find out different radiation patterns, then S parameters. So mostly all the result related to antennas, Smith chart and all are available in the software. And this is like 3D user interface, so user can directly drag and drop the components, design the CAD geometry, run the simulation. So there are like a lot of unique feature available in the software apart from for this antenna also. And this is the kind of visualization that is available in the software. So we can see that when we simulate this patch antenna, how these magnetic or electric lines of fields are getting generated. So that plot is given in this image. So we can clearly see that these are the like fringing effect fields we can see here. So the visualization part of the software is like very much strong, that we can plot any kind of we can simulate mostly like any antenna, and then we can plot the electric field, magnetic field, contour plot, quiver plot. Mostly all the plots are there which are required to do the research as well as basic understanding. Both the parts are covered by using this particular module. So okay, in this image we just plotted the electric field, the vector of electric field. Now we will see the user interface, and I will demonstrate few examples like how we can solve these problems. And later after that we will see what are the unique features available in this software. So when you see this user interface of the software, there are like 4 basic parts. First part starts with electronic design. Electronic design means we can drag and drop the component, we can make the designs, and we can simulate the designs. Second one is electromagnetics. So it is basically a basic electromagnetics design we are having. So here we are going to study the different laws, Coulomb's law and all that. Third one is the microwave design. In the microwave design, we are going to perform different kind of antenna simulation. Then again, microwave circuit simulation is also possible, like rat race coupler, ring resonator. These kind of things also we can do simulate in this particular toolbox. And then we also have these advanced EM problems. So right now, like in this session, we are going to discuss mostly on this microwave design, basic designs, and electromagnetics. there is advanced electromagnetic which talks about radar cross section and other advanced option. So it is going to start from basic electronic circuit to like electromagnetic to advanced electromagnetic. So I will just go in the basic electronics. So when we see this basic electronics toolbox, we can like drag and drop different tools like resistor, inductor, capacitor. Okay, for now I'll show you the charging and discharging of this capacitor. So we can like put this different components very easily. We can put step source, this sinusoidal source, all this source we can put. There are also chances that if you want to use these transmission lines and all these things, we can also do the port and we can study the S parameter also. For circuit, we can study the S parameter. So we added this kind of toolbox because in most of the time in the textbook, if you see, there are like S parameter, port parameter, Z parameter study, transmission line, then open-ended transmission line, shorted transmission line, then different loading on the transmission line, stub matching. These kind of concepts are also there. So by using this kind of tool, drag and drop circuit component tool, we can do different kind of analysis and we can study this kind of concepts. So this is like basic electronics. Most of the students are familiar with this kind of tools, like we can drag and drop the things and we can run the simulation. So there are different simulations like transient simulation, DC simulation, AC simulation, then S parameter simulation. So for now, I'll just run the transient simulation. So now I will plot the voltages at register terminal V1 and V2. Yes, so we can see that this is like charging of the capacitor we can see in this particular graph. So now suppose we want to see what is the effect of this resistor on this particular charging behavior. So we can double click on the resistor. We can change the value to let's say 2000, apply, close, and we will run the simulation once again. So after doing the simulation, what we are going to do is, again, we are going to plot the results. So I will plot the voltages. Now we can see that this charging time is quite increased. So suppose we want to like make a parametric study on this particular topic, then what we are going to do, we can assign this as a slider, register value as a slider. So here I will put register as R, apply, and what is R? So series resistance I will write. And we are going to change this value from 100 to let's say 2000 with step size of 100 and default value is equal to 1000. So there are like these 20 values which will be generated. Yes. So now we will click on OK. So once we assign this particular thing, now I'll close. So here in the command also we can see that this R is a slider, that series register slider is created. So we can move to the controls and we can see this slider now. So this is like a series resistance slider is created. So in this way, like user can create any slider and it will be added here. And once it is added here, we can directly save the design and run the simulation. So I'm saving this design at particular location. I'll store this on, let's say, I'll make a new folder on the desktop. RC circuit. So here I'll write RC, save. Now we are going to compute this particular result. So transient simulation we are going to save, run. So now it is going to solve this particular circuit for all the values of this desired R, and based on that we are going to like do the parametric simulation. We are going to change the value of R resistance, and we are going to plot how the curves are going to change. So now we will wait for this simulation to get completed. Because like we have taken a lot of points here, 1001. So we can reduce the number of points also in case we want to like see the result at very less time step. So after this understanding basic electronics, we will also understand other subjects like how we can do electromagnetics. Few example of electromagnetics I will give. After that, I will also demonstrate the antenna examples. So still the simulation is going on. We will wait for this. Okay, the simulation is completed now. Now we will plot the result once again. So voltages at 2 points of this resistor. Now we will see the effect of this slider. Means when we change the value of this resistance, let's say this when the value of resistance is 100, the voltage at capacitor W1 we can see, and when we increase the resistance value, now we can understand this concept how the effect of resistance is going to happen on this particular RC circuit. So in the same way, we can like make any parameter as a slider, and we can run this simulation. So for this circuit we have done, same way we are going to do it for other components also, like for CAD geometries also. That also I will demonstrate. So I will click on the new file now. Everything will be cleared now. There is no slider. Now I'll go to home. I will show you for few designs, like how we can make the designs and how we can make the sliders for those designs. So right now here we can see that there are no controls. Now I will be plotting these two circles. I will be drawing the two circles. And now I'm going to like make the subtraction. So there are like different operations. We can do addition, subtraction, intersect, sweep, extrude, revolve. So we can draw different kind of CAD geometries. We can perform different kind of CAD operations also. So when we are like going to design any kind of antenna, we can like draw the designs. We can perform the Boolean operations, and then we can perform the sweep, extrude, this kind of operations also we can perform. So now I'm going to sweep it to 3. So this is like circle 1, and this is circle 2. So for circle 2, suppose I want to change this radius from 5 to 10. So I will again assign this as R, preview, radius of circle 2, which is changing from 5 to 10 with step size of 0.1, default value is equal to 5. Okay. Okay. So now here we can see one slider is generated, radius of circle 2. Suppose I want to change the height also, so we can also do this for height. So multiple slider we can add here. Now I will just change this radius and we'll see how the geometry is going to change. So when the circle radius changing, entire geometry is getting modified. So this is the way we can like create our own widgets. We can make any kind of shape. We can compute the problem, and we are going to make the parametric studies on that particular thing. So I will also demonstrate one example of simple dipole antenna. What will happen if we change the radius of dipole antenna? So that example also I will demonstrate. But this is the way we can create our own sliders. We can create our own user interfaces. So I will go to now. And again, here also in the shape, we can have different kind of uh, options. Like we can assign different material conditions and boundary conditions and so on. Like we can draw the boxes, sphere, cone. So mostly all the CAD related operations which are there to make any kind of geometry are available. We can draw the boxes, and we can make different kind of assignments. Assign it as a sheet, assign it as a solid. When we go assign as a solid, we can assign simple dielectric, lossy dielectric, anisotropic dielectric, magnetic material, resistive material, general material, complex material, absorber material, human tissue, soil. So these kind of things we can assign very simply. Again, in the boundaries also we have different kind of boundaries. So PEC, PMC, impedance boundary condition, resistive boundary condition, then magnetic sheet, dielectric sheet, multilayer composite. So this kind of, so almost all kind of material possibilities are there. We can also assign this as an electric field source, magnetic field source, polarizers, and so on. So we will study these things when we are going to do with basic basic designs like microwave, basic electromagnetic designs. So mostly like these kind of facilities are there. I'll click new. Now we'll see the basic electromagnetic design. Suppose we want to like study the charges, what will happen when we like put the two charges and how the electric field, magnetic field will be generated by those charges. So suppose like there is one charge located at this particular point and another charge located at this particular point. For now, these are like two random points. So I will double click on any charge to see the value. So here we can see that this is the location of charge, and electric charge value is like 1 electron we are assuming. So by default it is like charge on the electron, but for simplicity I am taking 1, and here I will make, let's say 2. So if there are like these two charges are there, 1 coulomb and 2 coulomb, then what will be the electric field? So we will compute this. So now we can see here, when the both charges are there, 1 coulomb and 2 coulomb, then we can see the arrows and this charges densities and contour maps. We can also turn on these contour maps, cut planes, even arrows also we can turn off. So this is the way like these electric fields will be seen. Now I will be like double clicking on this charge, and instead of 2 I will make this as a variable, let's say C. And now I'm going to change it from -2 to +2 with step size of 0.1. Default value is equal to, let's say 0. Okay. So now we can see that this slider is generated here. I did not written any description, so description here is like blank, but we can write what is this C in the description and all. And now we will click OK, and now compute. So there is like only one charge when the other charge is 0, and we can see that these electric fields are like outside. Now when we are changing these charges, we can see when the another charge is -1, this will be like attractive force. So when it will be attractive, we can see the lines of electric field lines are showing this kind of closing loops. And when both the charges are like +1, -1 like this, so we can see that this how these lines are changing. When they become positive, so that becomes repulsion. So we can see these repulsive lines also. So this is the way we can study these charges. Similarly, we can also have this magnetic lines couplings. Even like we can make the charge location also. Suppose I want to change the location of this charge. So here in the Y, I will write Y preview. Y is changing from 0 to 10, let's say, with step size of 1, default value is equal to 0. Okay. Okay. So now we can see if I shift this charge from left to right. Okay, I will just add some value here. I'll make positive and negative. Now if we shift this charge, I'll draw the XY plane. Yes. Suppose I will change this Y location of this charge. So we can see when the Y shifted upside, how these fields are changing. So this way we can understand this we can create multiple slider element and we can understand how this charges movement and all these things are happening. Now I will click on new. I'll turn off this contour also. I'll go to magnetostatic. We will define a circle, current carrying circle or current carrying loop. Assign this as a radiator. So I have made this particular circle of some copper wire and now we are going to put the excitation on this circular loop. So, okay, I'm taking this excitation from here. Current excitation we will apply. So here, if I double click, we can see that this is like current amplitude at this particular location. We have applied the current. So this is like static current. So this is like current carrying conductor of circular loop. The current is having the magnitude is equal to 1. Now I will compute this and we will see the field lines, flux lines. So when we are having this circular loop carrying current, the flux lines will be like this. Suppose I will add one more circle. We can also create the lines and we can plot that things also. So I will like add some Z value here. Z is equal to, I will say H, or for now I'll just make 10, 20. Okay, 20 is fine. And now I will assign this as a wire. And after assigning this as a wire, I will put the current source excitation on that wire. So I'll take this current element, current source, and put it here. So now both the currents, there are two coils having the current on them. And now we want to see by Servot law that what will be the magnetic field line coupling. So we can also like compute that coupling and we will be plotting those flux lines. So yes, so this is the way like this magnetic field will look like when we are having these currents in this way. So we can again change the values of current and we can see how this current, when we change the values of current, then how this magnetic fields will change and all. So in this way, we can like simply understand this magnetic field line couplings. Even if we want to understand this contour plots, Weaver plots, we can also plot these kind of plots. Yes. So this is the contour plot. Okay, this is the contour plot. So in the contour, we can see that these flux lines will be normal to the contours. I'll turn off this contour and cut planes. So this is about the magnetostatic, like we can again add multiple wires and we can do a lot of things here. I'll turn off this. I'll take a simple wire and we will see what will be the magnetic field generated by the simple wire. So I just put the current source here and now we are going to compute. And plot the magnetic field. So when we are having this kind of wire, we can see that these magnetic fields are circular in the nature. So this is going to help you understand this basic magnetostatic things. I'll turn off these connections. Okay. So next, like we can take the charges also once again, and we can create different magnetic fields, electric fields. So for now, I'll be putting these charges here. Now we will be doing some moving charge analysis. So in the moving charge analysis, what we are going to do is that we will be okay. Yes, so we are going to put the boxes, and we are going to assign these boxes as a magnetic field or electric field. So I'll just make this height. So we can change the dimension of any box. Like we can create any source, we can change the dimensions. So I'll be making this like -5 to 10 or -15 to 30. So in this way, we can like make these charges and this kind of boxes where we can apply this magnetic field and electric field. So we can assign this electric field, magnetic field like this. Here we need to enter the exact values that we want to assign as a electric field or magnetic field. And here also again we can select the charges and we can assign the velocities to different charges. So once we assign the velocities, this particular charge will become a moving charge. And what will happen if this charge moves under this particular magnetic field and electric field? So these kind of computations are also possible. So now I'll click new. Then there is also one more toolbox where we are going to understand the polarization. So for polarization, what we are going to do is that we are going to draw these rectangular shapes as a waveform generators. We are going to assign them as a wave port. So whether we want this field to be in EX direction or in EY direction, that we need to define. So for now, I'm making it in the EX direction. So this is a particular port. Now we are going to compute the waveforms for this particular port. So here, okay, we can see how this particular signal will be generated. For now, I'll be shifting this box to make a proper waveform tool. So I will draw the box and make it from, let's say, in the Z, I will write 0 to 250. Here I'll write -100 to +100. And okay, here I want to understand it in the Z axis. So I will put the Z axis points more. So it will be like, I'll put 250 points for the Z. Yes, that means now we can see this grid, how we are going to see this particular wave. So I'll click OK. Now we are going to compute this field again. Yes, here we can see how this electric field and electric field will generated. I'll make this dimension exactly at the center. So -50 to 100, -50 to 100. So this is the way like this electric field is generated and getting transmitted. Suppose we want to make another waveform. So I will assign this second waveform generator. I'll shift this waveform generator to, let's say, 20. And this another waveform generator. So we are just making the waveform generators. So located at -50 to +50. So this Z location will be 0, and I'm changing the color of this particular waveform generator. I'll take another color like, okay, this one I will take. And again, for this also, I will assign the wave port in the Y direction. Now we can see that these two waveforms will be generated. One waveform will be generated by this particular port, and another will be generated by this port. So in this way, we can understand like when there are like two waveform EX direction, EY direction, and when they are like shifted by some distance, then how we can achieve this kind of elliptical or circular polarization. I can also change this value. Let's say I will write here H and preview. H is changing from 0 to, let's say, 30 with step size of 1 and default value is 0. This is like separation distance. Okay. Now again I will compute. Yes. So when both the planes are located at the same place, it will be linearly polarized. We can see white one is the resultant waveform. We can see here how this waveform is generated. The linearly polarized waveform we can see. And now when we like have some phase difference, this linear will be changing towards circular. Here we can understand this concept, how it is going to shift as a circular. Again, it is becoming linear. So elliptical polarization, circular polarization. So at this particular separation distance, it is becoming somewhat more circular. So student can find out where it will be circular and where it will be elliptical. Here it is like left elliptical, right elliptical. So based on like when the when the separation distance becomes lambda by 4, it is going to give us the perfect circular polarization. So like this way we can like different subjects or different concepts which are there in the electromagnetic we can study. There are again wave concept. We can create the dielectrics, and we can again observe that what happens when the field goes into the dielectric. We can create the polarizers, and we can understand this wave nature, magnetic field, electrostatic, magnetostatic, moving charges. The third component which is there is antenna designer. So in the antenna designer, again, we are going to create multiple antennas and we are going to simulate those antennas. So for example, I'll be like making one simple patch antenna. We'll see how we can design the patch antenna and how we can simulate the patch antenna. So for that, I'll be like first drawing the box. Let's say this is like randomly this box I have drawn. Now this particular box is having dimension from like 6 millimeter by 6 millimeter. So I'll double click. So as this dimension is 6 mm by 6 mm, I will be writing -3 to 6 and 6. So in this way, it will be like extending from -6 to +6. And the height of this particular dielectric is 0.787. So we will click OK. So in this way, we have created this dielectric block, simple block. Now what we are going to do is we will be making a rectangle on the top, which is for the patch. So, and there will be like bottom will be bottom will be metallic ground. So I'll just draw this bottom first. So here it is like -3 to +3, means it will be like 6, length is 6 and width is also 6, and it is like ground, so z is equal to 0. Now we will move to the upper face, and on the upper face we are going to draw the geometries. So basically all kind of shapes we can take, and we can do the Boolean operations like this. So I'll be drawing one rectangle here for rectangular patch antenna. So this particular patch is changing from y is changing from -1.5 to 3. So the width along this y-axis will be 3, and in the x it is changing from -2 to 4. The length is 4, -2 to +2. So the length is 4. Now we are going to draw one more line, which is the excitation. So let's say I'm drawing it randomly, but again I will double click and I will change this dimension. So here z will be 0.8787, 0.8787, and y will be -3 to 2, and the x is going to change from 0.3. The width is 0.6, so I'll enter -0.3 to 0.6. So this is the feed line. So now we are going to make the union of these two feed lines. Next thing is that we need to assign one more, we need to make one more rectangle where we are going to feed this particular signal port. So I'll create one more rectangle like this. Again, here we will be entering this dimension, which is like -0.3 to 0.6. Y will be changing. Okay, 787, and here it will be 7. 0 to 787. Height is changing from 0 to 787. So this is the way we can like simply create this kind of feed lines and all these things. So in case we want to change this color of this rectangle, we can also change the color. Suppose I want to make this port as a red, so I'll make this red and click OK. So now you can understand that this is the design: ground plane, box, and the upper patch. But till now we did not assign any metallic properties. So we will go to the CEM. Now we will assign this as a PEC. We'll click OK. So this particular part will be added to PEC. Then ground plane is also PEC. So I select the ground, assign sheet as a PEC, and the dielectric also we are going to assign as a dielectric. This box we are going to assign it as a dielectric. So I'll right click, assign as a dielectric. So assign as a solid. So here I'll be taking this simple dielectric. Default value is like 2.2, but in case we want to change this dielectric constant, we can change these values also, and we will click on OK button. So now we have added these three parts. After assigning this three material combination, we have added this into the parts. The next thing is we are going to assign the excitation. So for that, we will be like taking this port and drawing the integration line. Yes. So we can see that this integration line is drawn. You can see this arrow is there. So after that, we can like save this particular design. So we will click on save button, and on the desktop again, I will go to this. Okay, same folder I will save RC circuit. Here I will make patch. The next thing is that we are going to do the meshing and apply the boundary condition before running the simulation. So I will take the mesh from -1. Sorry, I'll keep this as it is. It was like -3.60. This is fine. Like whenever while doing this cube dimensions and all, it is fine. We can keep it as it is also. So I'll be dividing it in 20 by 20 for faster simulation, but the default values are correct one. Even if we don't change it, that is fine. And just I want to observe the electric field at the upper side. So because of that, I will be entering like 2, and I'll be increasing this to. Yes. So now we will click on OK. So this will be like our dimension. And after that, we are going to assign the boundary conditions. So by default, boundary conditions are CPML boundary condition, like perfectly matched layer. So we need not have to change this. I will keep it as it is. Or even if someone wants to like make metamaterial design and all that, so in that case, they can assign it as PMC and all these boundary conditions they can change. So user can change these boundary conditions, or user can keep it as it is also. So now the next thing is like we are going to save this design and we are going to run the simulation. So in order to run the simulation, first we need to define the frequency range from where to where we want to run this simulation. So I'm running this simulation from 10 gigahertz to 40 gigahertz with 27 gigahertz as a operation frequency. Now we will click on run simulation. So in the simulation also there are different techniques: PEEC, FDTD, ray casting, combined technique. So for now we are going to run this FDTD technique. I will also explain you the advantages of PEEC technique. So for now I'll click on simulate button. So it will start solving this particular problem. So software is like very much faster. Even if the computer configuration is not high, then also you can run this simulation effectively. So we can see like at very less time, this simulation is like going to get completed. Okay, the simulation is done now, and we are going to plot the different results. So there are like different 2D and 3D results that can be plotted. Okay, I guess. I guess while connecting the charger, I have entered some wrong button. I'll open this design and simulate it once again. Hmm. So now I'll be opening this design. It was on the desktop RC circuit patch. I'll just check whether it was simulated. Okay, it was not simulated, I guess. Now what we are going to do is we are going to okay. Okay, that union part, till union part we have saved. After that, it was not saved, so I will make this union. Then we are going to assign electromagnetic properties. Assign solid dielectric. Then assign the excitation. I will open this example rather than creating it from the scratch. In the examples, I have this patch antenna. Okay, so this is the same patch antenna that I have designed right now. But here the only difference is that here we have given some height also for this metallic patch. I'll show that height. So if I double click, okay, here there is height also, like this width, height. So these are the exact dimensions, how it is changing from like 0 to 3.06. So these are the exact dimensions for this particular patch antenna, height 787 and all. Okay.
Dear participants, there is some technical difficulty with the resource person. So let us wait for another 5 minutes. He is connecting from a different laptop. So kindly wait patiently. In the meanwhile, we can take the group pick of this particular session. I request all the participants to turn on your camera for another couple of minutes. I request all the participants to turn on the camera. So I request all the participants to turn on the camera. Only very few has done. Thank you, participants. We will wait for a couple of minutes. No, the resource person is joining from a different laptop, so we'll wait for another couple of minutes. Thank you for the cooperation.
I will discuss that what are the unique points available in the Tarang software. So before that, if it is possible, I will again start the software and show you the example of horn antenna, just in order to show you that how we can see the electric field, magnetic field, and radiation pattern. But by that time, I will go to the PowerPoint and I will show you what are the different features available in the Tarang software. So basically, when we see this Tarang software, there is like CAD design tool, then CEM tool, mesh control tool is also there for advanced meshing. Computation, in the computation, we are having different computational technique like FDTD, PEEC, and so on. Then circuit model generation is also there in the Tarang software. This is the unique feature that is mostly not available in other softwares. So when we talk about the CAD design, we are having a facility that we can create our own sliders. And when we are like changing any one parameter, the entire geometry is going to modify. There is also a programming support in this Tarang software that when we want to make a complicated geometry using for loop, if else condition, that is also possible. We can make a complicated geometry by using this programming. Then in electromagnetic feature, there are mostly all 3D materials supported, sheet material supported, boundary conditions we can apply, lumped and distributed loads we can also apply easily. Source and excitations also supported like lumped port, voltage source, current source, and plane wave and point source, radiation pattern, so on. In the result, we can plot mostly all kind of 2D and 3D results with zoom, pan, rotate, all the animation controls are also available. It is also possible to define very complicated geometries where the material is changing very much with the equation. So that kind of equation-based material modeling is also possible in this Tarang software. And again, in the boundary condition, we can change the boundaries wherever we want. So in the mesh control, there are like different node advanced facilities like node can be adjusted interactively. We can also visualize the voxels, and the voxel models are very high quality voxel models. So these high quality voxel models are very much useful for doing FDTD analysis, or even the triangular meshes can be used for PO as well as method of moment. So it includes different kind of meshing possibilities, like we can create 1D, 2D, 3D meshes. Then in the computation engine, we are having PEEC, which is like one of the most unique and beneficial method. Then there are like different kind of problems which Tarang can solve very easily. Like when we are having a multiple cables, wires, which are fed by different phase currents, and different phase differences are there on this excitation, then we can solve this kind of problem very easily. Even the array of different type of element is also possible. In the circuit modeling, this is the particular circuit equivalent example of a patch antenna. So here we are like having the inductors and capacitors. So the software is able to generate this kind of circuit models for any antenna geometry or for any microwave geometry. So whenever we draw any problem, we can like design this kind of, we can generate this kind of spice netlist, which includes all the inductors and capacitors. And that particular thing will be generated in 3D, so user can rotate it and user can see the values at different points. There is also a data center. In the data center, we can plot the tables. Whatever the data generated internally, we can plot the data tables for any data. And after plotting these tables, on the table, we can select any row and we can again plot 2D data also. We have recently integrated our solution with different algorithms in the data science, which are like TensorFlow, Keras, Pandas, sklearn. Even like for classroom teaching, we have integration for Moodle, then Jupyter Notebook. When we want to do circuit simulation, we can also have LT-SPICE integration. Even the workspace, we have integration with MATLAB, and Amazon Web Cloud Services also we have made the integration. So this is like very advanced integration capabilities that we are providing. For some user, we have also provided the integration of virtual reality and augmented reality. So we can see the result in AR as well as VR. All the 3D, 2D, these results which are generated, which that can be interactively changed by using the remote controls, and we can see this in the VR boxes. So there are like different approaches we can use the softwares. So one is like educational aspect. So when we talk about the educational aspect, we have delivered like mostly very much advanced proposals for the education, because when we see the need of current student, generation Z student, that they want a software solution which is quick to learn, quick to start. They want everything at same place. They want web interaction based online solution, and they want to do a practice based learning. So we are going to offer these pedagogical solutions which is useful for generation Z student. Even teacher also want a pedagogy based solution where they want to add their own things into the software, and they want to use the software for classroom teaching. So in this way, we can prepare the example, we can share this example simulation model with the student can also interactively play with this simulation model, and it can be used for classroom teaching also. So there are like different mode of operations, which are like companion mode, then full integration mode. So these are different modes in which the software works. So basically like teacher can create the nodes, and they can create the simulation models in the software. There is a facility directly in the software, they can create the nodes. That also I will demonstrate. Yeah. So when we go to this like simulation, I'll just open one of the example. Let's say this horn antenna. So I'll be plotting the electric field, magnetic field. So okay, so this is the way like electric field of this horn antenna is plotted. So we can also play the animations, and we can do multiple controls on this. So I'll be like playing the animation. We can see how the fields are going to propagate in an animated format. So waveguide and many things we can design and simulate, and we can see the fields. So it is able to solve different kind of antennas, even different kind of circuit also it is possible to simulate, rat race couplers and all. We can change the sliders and we can observe the values at different locations, different positions. We can turn off or turn on the contours. We can see how these arrows are changing. How the modes are going to change, how these modes are going to change, we can see when it is propagating. So initially it is like this, and when it is going ahead, so this is horn antenna. So in this way we can interactively plot all these results and we can see how the flux lines, arrows are changing. Also there is a tab where if teacher wants to add the notes, then they can also write their notes also, like horn antenna example, like that. And when they save these notes, so and when they give this content to the student will see notes as well as simulation model, both the things they will see. So there is facility that we can change the font. We can let's say we can do multiple things, like I have increased the font size, let's say 16. I'll make it bold. I can change the color. Then I can add the images table, multiple things we can do here, and we can create these notes and we can save the notes also. So it is also possible that we can interactively create our notes, simulation model, everything we can give to the student, so that it will be very much useful for pedagogical learning. And there is like a lot of work we have done in machine learning side. We also published several research papers. Again, for academia, we have created this kind of course content also. For few university, we have created the course content. We have delivered around 60 simulation models. So almost all topics are simulation based. Students are able to perform the hands-on practices, starting from basic electromagnetic to advanced microwave design. And the course covers most of the applications of electromagnetic. All the student at the end, student will be able to make their own designs in Tarang software, perform the project as well as publish the research paper. So student has published research paper also, and in the project also they have made the project like implantable antennas, then antenna applications in IoT, biomedical, these kind of things also student had done. For different customer, we have given the integration option also. So this is one of the example that we have done with the DRDO, where they wanted to like find out the trajectories at different points when their aircraft is moving, the RCS analysis and all. So there is like bistatic radar located at this rectangular box, and this particular vehicle is traveling over this particular trajectory. Yeah, so we have along with the software, we have provided different kind of additional offering with different universities also. So yeah, thank you for listening our presentation. In case you need further information and further detail, we can also provide that detail over phone call. You can note down my email ID as well as you can note down my mobile number is 83902 40903. I'm also there on the WhatsApp. So WhatsApp as well as LinkedIn, Facebook, you can search me and we can interact over these particular simulations.
Thank you, sir. Thank you for your excellent presentation. And it was a very interesting session.
Thank you, sir.
We do have a question, sir. I'll just post the questions.
Yes, sir.
Just give me 1 minute. So one of the participant has requested whether do we have a student free version or any trial version is available at cost.
Yeah, trial version we did not given to many universities because it is like trial version is mostly given when they want to understand the software. So most of the time, whenever we demonstrated the software, institute said that they want to purchase. So because of that, we need not have to give the trial version. But in the pandemic time, we have given the free versions to make the interactive learning possible. We have given these free versions to more than 25 universities. They use the software in the lockdown. Students perform the practicals. They submitted the reports. We have given the cloud version of the software in the pandemic time. So it was like there for 2020 as well as 2021 also we have given till July month. And now we are mostly like, it is when someone require it, maximum 1 week trial version we can give.
So, and do we have another question, sir? Can we export the data parameter in XLX, CSV?
Yes. XLS, CSV, that thing is available in the software. In the simulation also, we can like select this option. There is like, while simulating the problem, it asks like CSV format you want to save. Even like this workspace is there. So this workspace you can also export to MATLAB. So there is possibility we can export all these results.
Good afternoon. I am Professor Jansi from Siddharth Engineering College.
Yes,
Really,
ma'am.
I can appreciate you for this new version of that one. Actually, we are working in the CST and HFSS. I heard from you only this one. It is very nice topic, very interesting. Okay, we'll personally contact you about this software. Okay, thank you.
Yes, thank you, ma'am.
Okay, very nice presentation.
Thank you, ma'am.
Thank you, sir. And I do personally have a question, sir. Now, being in research,
Yes, sir.
we'll be using ADS, CST, and ANSYS for designing the antennas. So, what is one particular thing which is great in your software when compared to ANSYS or something like that? Because for example, in ADS, you will not be able to draw that particular circle. We will have a lot of difficulty in converting that oval into a circle. But so what are the like this? Do you have any other peculiar advantages in this particular software when compared to other software?
Yes, sir. So I will say that for teaching purpose, this is the best software because it is very easy to draw any kind of geometry. Just now I have simulated a patch antennas, drawn that designs. So for student, it is very easy to draw this kind of designs and simulate it. And even like most of the software doesn't cover complete syllabus of electromagnetic and microwave, but this software is like going to cover the complete syllabus as well as it is applicable for research as well as project. So so this is the best advantage. One of the technique that we are having is the PEC, equivalent circuit generation. That particular technique is mostly not focused in another softwares. Again, this Biot-Servot law, Coulomb's law, these are the things student will not be able to do in ADS. So again, these kind of things also they can do it here. So yeah, it is like a complete solution that student needs, teachers needs, even a researcher also can use this software.
Yes, thank you, sir. Thank you for that wonderful presentation. It was really inspiring session. Thank you for that. And
yes, sir.
Yes, thank you, participants, for your active participation. We will break for lunch, and the third session will start by 1:15 p.m. I request all the participants to join the third session on time. Thank you, sir. Thank you, Swapnil, sir.
Thank you, sir.